this next part of the video, I want to talk about some vocabulary relating to zeros of polynomials. So we've talked a little bit about the factor theorem and the remainder theorem, and we'll start with those concepts here. Just the following ideas are all equivalent. If you get a remainder from synthetic division by the quantity x minus c, you get that remainder to be 0. We just said that that means that x minus c is a factor of f of x. That was what we called the factor theorem. But we also concluded in a previous video that that same remainder of 0 could mean that the number c is a 0 of the function. That is, when you plug c into the polynomial, you get a value of 0. Here are some other things that are true. We can call c an x-intercept of the function if it's a real number. That is, if we were to graph this polynomial, and here's a typical graph of a polynomial, the c values, which give you a remainder of 0 when you do synthetic division, those are exactly the places where this polynomial crosses the x-axis, and you can see that there are 3 of them here. Here's the first one on the left. There's 2 places on the right. Those 3 values are the ones that would give you a 0 remainder when you do synthetic division. So we call those things x-intercepts. We could also say that c is a solution of the equation f of x equals 0. And finally, we can say that c is a root of f of x. So all of these different terms, vocabulary, solution, root, 0 of the function, x-intercept, they're all basically interchangeable. Finding the zeros of polynomials is something that we're going to be focusing on here going forward. So when I think of finding zeros of a polynomials, I like to think of it in terms of some of my favorite movies. For instance, in the movie Die Hard, Bruce Willis's character kind of runs into a whole bunch of terrorists that have taken over a high-rise building, and as part of the movie, he sort of has to count up how many terrorists there are. He gets a hold of one of their radios and listens in, and he does a little quick math and figures out how many bad guys there are. And throughout the movie, you kind of count them down as he kind of takes them out one by one until he gets to the big bad guy, Hans Gruber, and finally has to take that last terrorist out. So I think of finding the zeros like counting up the bad guys in a movie like this and just kind of looking for them. So one of the first concepts that we should know is how many there are. And here we come to an idea called the fundamental theorem of algebra. So in terms of zeros of a polynomial, and there are other ways to describe this theorem, but in terms of zeros of a polynomial, the fundamental theorem of algebra says this: every polynomial f of x of degree n has exactly n zeros in the complex number system. Exactly n zeros. So the degree of the polynomial is how many zeros you should be looking for. Remember, the degree is the highest power of x that we see in that polynomial. Now, some of the zeros may be real. Some of them may be non-real. That is, they might involve the imaginary constant I. A couple of other things that we should bear in mind is not all of those zeros will be unique. Some or all of them could be repeated. So I could have a solution that happens more than once. The same number is a solution of the equation more than once. Solutions that have multiplicity p are counted p times. So if a solution happens twice, that means it has multiplicity 2, and you get to count that solution twice. If a solution has multiplicity 4, then that solution happens 4 times. You get to count it 4 times as you're counting up the number of zeros in the polynomial. But the fundamental theorem of algebra really is key, because we don't want to stop looking for zeros before we've found them all. Right? John McClane didn't want to stop looking for terrorists after he taken out 3 of them, if there were still 5 of them left, that would not be a very good idea. He would not be able to defeat the terrorists. If we're looking for zeros of a polynomial, we don't want to stop looking until we found them all. Now, on the other hand, we don't want to keep looking for more if we have found them all. So if our polynomial only has 3 zeros, we don't want to find 3 and then keep searching around for more. That would be a waste of our time. The next concept relating to finding zeros, I like to think of this scene from the movie The Matrix. So there's these 2 bad guys, these henchmen. They're basically twins, and they're always just referred to as the twins. And this is kind of shown up in other movies as well, when sometimes the bad guy has a whole bunch of henchmen around him, and they're twins, and so the hero is kind of working his way, trying to fight through to the bad guy, and he defeats one of the twins, and he turns around, and suddenly there's another one just staring him in the face and confusing for a second, like, didn't I just beat this guy? The next concept tells us that sometimes the zeros of polynomials come in pairs, and it's called the conjugate pairs theorem. What it says is that complex zeros always come in conjugate pairs. That is, if you've got a polynomial p of x and it's a function whose coefficients are all real numbers, and if a plus bi is a zero of that polynomial, then a minus bi is also a zero of that polynomial. So for instance, if 3 plus 7i is one of my solutions, I can always be guaranteed that 3 minus 7i would be another zero of that polynomial, another solution of the equation p of x equals 0. The third concept relating to zeros of functions, I like to think of this movie, The Usual Suspects, or maybe the movie that this line comes from, Casablanca, where one of the police officers says, round up the usual suspects. So this is called the rational zeros test. And it's a way of rounding up the usual suspects, of finding some possible zeros for our function. This used to be a whole lot more important back in the old days, before there were computers and graphing utilities like a graphing calculator where we could find some of the zeros that way. Here's what the rational zeros test tells us. We should check all of the fractions in the form c over d, where c is a factor of the constant of the polynomial and d is a factor of the leading coefficient of the polynomial. So we create all of these fractions, all possible fractions of these types, both the positive and the negative versions of these fractions. Sometimes we refer to this as the last over lead test, because the constant is usually the last number that you see in a polynomial, and the leading coefficient is usually the first number that you see in a polynomial, the leading number that you see. And what this does is we create all of these fractions, is it provides us a list of possible integer or rational zeros. Now, this list is not going to include any irrational or complex zeros that your polynomial may have, but it does give you a good list to start from. And what we're going to find out is that sometimes this list can become pretty large, and we won't want to check every single one of those suspects to see if they are a zero of the polynomial, but it can help us set up a calculator window. In the next video, we'll see some examples where we'll use all these concepts to try to find zeros of polynomials.